Okay, good morning. This is the Gardener community meeting. This is a recorded meeting, so don't talk about something you don't want to see on YouTube later. Today we have 3 topics. First, Tim will talk about test machinery and of what they are working on. Then Rafael will give a demo on out-of-tree CoreOS controller. And finally, Peter will give an introduction to how we handle release notes. So Tim, I think you can take over.
So, hello, can anyone hear me?
Yes.
Okay, so great. Then I share my. Okay. Can all of you see my presentation, or?
We can see it, yes.
We see your PowerPoint screen.
Okay, that's good. Okay. So yeah, today I want to
not the full screen, by the way.
Not the full screen. Ah, here. Okay.
No.
To the front. This one, I think. Now?
Yes, now it's full screen.
Okay, great. So, yeah, today I want to give you a quick overview about our new test machinery, which will be or is our new test framework or test environment for executing our integration tests. But before I want to start and talk about the architecture and what is the test machinery and what it consists of, I want to talk about why do we even need a new testing environment? Because for now we already have a CI/CD system, and this CI/CD system runs our integration tests during releases with a grunt job and on several stages. So why do we even need a new environment for that? So, and to understand that, I want to give you an overview about what we have or where we are coming from, what are our current tests or what our previous tests look like. So most of our integration tests are written in Bash and in really huge Bash script. So this means that we have 1,000 lines of Bash tests, which testing like creating a shoot, deploying a guestbook app, testing some network policies, and then leading a shoot again. And all this in one big script, which is not really maintainable and not really readable. So if you're not into that, if you're not into Bash or want to start new at a project, it's really hard for you to get into the test and see what is going on. And another bad point, another pain point of Bash is that a really bad error handling, and you have to do everything on your own. So we really want to get rid of this and move to a better language or a better environment to run our tests. Then another thing with our current tests is that the execution of these integration tests are split. So for now we have, for example, one integration test for the Gardener and multiple other integration tests for the different modules like the machine controller manager or performance tests or something else. And all of these are split into different teams and also the execution of this, which also means that we have no common output and no central overview about what is going on in our landscape. So we do not have a common reporting about what is going on and which component, what is the status or what is the quality of the different components. And also because of the split execution, all of these integration tests are implemented their own fundamental functions. So fundamental functions means for us, for example, like creating a shoot, setting up Gardener, deleting a shoot again or upgrading a shoot. And these fundamental functions are implemented in every of these projects, and every of these has to be maintained on their own. So for example, if Gardener changes an API or anything is changed in our landscapes, we have to maintain we have to maintain these changes and all of this and all of these duplicated functions. So therefore, we have no reuse. And yeah, we really want that to be reusable and to have one point where we can maintain these fundamental functions. So in conclusion, we have three main pain points, which is first of all, our current test environment is hard to maintain because of the split environment, because it's mostly written in Bash, and yeah, because of the duplicated functions. Then what else is hard to keep track, so we have no central point of reporting, and we do not really know what is going on, what tests are run for which control and which environment, what do they look like. And another big pain point is it's really hard to write and integrate new tests. So because for now, you do not really know where you have to, or in which environment you want to go. Do you want to integrate in our Bash script? Do you want to integrate in any other integration script? So therefore, this is really bad. And what we want is we want to get rid of all these things and make this better. So what do we really want? Or what we want to get out of the test machinery or of a new environment is, first of all, we want the easy addition of new integration tests. So we want to animate our developers and the other teams to write new tests and to integrate their tests in our central framework. So which means that, for one thing, we want to allow reuse. So we have one single point for these fundamental functions, so that not everyone have to write their own. This is also better because I think for a module or for a specific module, you do not want to care about the environment. For example, like creating a shoot, you just want to write your test and want to see if the Kubernetes cluster or the garden is working fine, and you do not really care about these basic things like creating a shoot, checking itself, waiting for it to be up, and all of this stuff, or deleting a shoot, or safe delete a shoot, maybe error handling and cleanup after all. And yeah, we want that to be as easy as possible so that new tests can be easily integrated and just have to be so that the developers itself can focus on what he really wants to test and not test everything and not test something that is already tested. Then another big point is saving costs because of the split environments. All of these environments need different Kubernetes clusters and run several times a day. So if we can merge them together and maybe reuse these shoots, reuse some Kubernetes clusters, we can really save our costs. Because in our case, when we release, we do not have just to test one Kubernetes version or the 3 supported versions. We also have to test the creation of shoots across all cloud providers, and then also in all Kubernetes versions, which results in a lot of clusters and a lot of costs from our side. And if we can merge all of these tests together and share these clusters, we can really save our costs. Another big point that we want to say is that we want the test to reside near the code testing, which means for now our integration test is in a central repository and has not really it's not really linked to the Gardener tests. And what we want is that we want the test, or we want the test code to reside in the code testing to have several advantages. For example, the versioning of GitHub and stuff like that. So we do not have to care about this. The fifth point is the central execution. As I already said, we want a common output and a central reporting to get overview about our current landscapes, about the current stability, and about the quality of the test, about the quality of the landscape. So therefore, we want to help make a release decision and and really have to, so that we have an overview about what is going on. Can we release this Garden release, or do we have to fix some things? And this. And the last big point is that we do not want to replace our CI/CD system, because we already have these things, and all these things are implemented by our CI team. So we do not want to care about GitHub webhooks, about building images, and or executing unit tests. So we want to integrate into the CI/CD system and don't want to replace it. Yeah, and these points or these topics lead to our implementation of the test machinery. So the test machinery itself consists of two main resources. The one is a test run, and the second one is a test definition. A test definition defines the test itself. So for example, if I want to deploy a guestbook and run some tests if the ingress works and stuff like that, this is one test. So a test definition describes the execution. So for example, the executable that I want to execute, in which image do I want to execute it, and yeah, some specific configuration. And yeah, these test definitions are split across different repositories. So for example, different modules to reside near the code they're testing. So, and then we have test run, which is which brings all these test definitions together. So a test run therefore consists of locations, configuration, and a test flow. So the location points to repositories so that we know where to search for test definitions. So which means that they point to a gardener, to machine controller manager, to etcd, of the stuff, so that we know where do we have our tests, where do we look for tests. And then the test flow defines exactly which test to execute and in which order. So therefore, the test machinery looks in the test locations for the specified tests, and then executes the found test definitions in the order that is specified in the flow. And yeah, with these two resources, I want to go to the big picture or big architecture picture. So you can see on the left side our repositories with the code itself, the test code, and test definition. And as I already said, that we want to integrate into CI/CD, but not depend on CI/CD. So therefore, we can be triggered by CI/CD or even manually by just kubectl deploy and stuff like that. So therefore, a test run is triggered, and our test machinery watches for test runs. Then it searches the locations and the repositories for specific test definitions and generates the workflow. The workflow is a Argo workflow, which is another component. So Argo is an open source project, which is a controller that handles pipelines and workflows. So we do not want to write our own pipelining engine or workflow engine. So therefore, we want to reuse open source things that are doing that good. And so the only thing that the test machine controller does, it abstracts this Argo workflow and generates, and parses the test run and generates an Argo workflow. And then Argo itself executes the test on our behalf. And when we go next, we see a more detailed overview about our test machinery. And I think the only thing that is that I want to point out here is you see on the downside, you can see the concourse, and that is run by the test runner. And also this that the test runner watches the test run to be completed. And also the test runner tests these different environments that I already said. So like different versions, different cloud providers, and then writes the results of this test to Elasticsearch. So this is our central reporting environment. So we want to have everything in one Elasticsearch database to have later Kibana dashboards and see what's going on in our landscape. Yeah. So, and as you can see here, the test run itself is a CRD. So, yeah, these are our two resources, which are described through small YAML files. On the left side, you can see a test definition, where you just specify the comment you want to run, the arguments, and the image. And on the right side, you can see the test run. There we can come back to my to a few slides before, where I said that a test run consists of test locations, configuration, and test flow. And there you can see that test locations are GitHub repositories with a specific division. Then we can define configurations like environment variables that are mounted to the tests or files that are accessible in the test itself. And then we come to the test flow, which is a two-dimensional array, which basically means that everything in the second dimension is executed in parallel. Everything in the first dimension is executed in serial. And what I also mentioned here is that you can see we cannot just state names of test definitions. So for example, like creating a shoot and then doing the guestbook test and deleting a shoot, we can also specify labels. Labels mean that the test machinery automatically searches in the test locations for test definitions that are labeled default and executes them in parallel or in serial if they have a specific behavior defined, as you can see on the left side. So, and this is one big point that we also have when we designed the test machine, is that this easy integration. And the label, and this label feature is really one thing of that, because the only thing that you have to do when you want to integrate your own test is you create a repository with tests on GitHub, or even have already a repository with tests. Then you create a test definition in a specific path with things you want to execute and the tests you want to execute. And then add the repository as location in the test run. And then in the next run, the test machinery automatically picks up the test definition and runs the test with all the other tests that are already specified in the test run. And for that, you can also visit our repository with the Getting Started guide, with where we have a more detailed view about how to integrate and how to write new tests for our test machinery. So, and then I want to give you a quick demo about test machinery. So I think you have to share another screen. This one. Can you see my editor?
Yes.
The font size is a bit small.
Yeah, I increase it.
Okay.
So yeah, this is the demo test run that I want to show you now. So basically, we search in the Gardener repository. Under this revision, we want to execute a shoot app test. And then we want to execute all tests that can be found that are labeled default. So now I jump to our Gardener repository. So there we have our Gardener repository, and we go to test definitions. We can see there our shoot app test. And we can increase the size a bit. So this is a real example that is run currently in our pipelines to test basic behavior of our Kubernetes clusters. So yeah, if I jump back, and now yeah, we want to execute this, and then we want to execute all that can be found, all that are labeled default in this repository, which should be the shoot app test and a seed logging test, which tests some logging in the seed. So we expect that the test machinery picks up or finds both definitions and executes them in parallel. So therefore, I jump to the command line and show you that I already deployed the test machinery, and I also created a shoot or a Kubernetes cluster before to save some time and to not get to our whole workflow, because that takes some time and it, I think, is unnecessary to get. So
can you zoom in a bit?
Sure.
Thank you.
Yeah. So as you can see there, we have our workflow controller, which is the Argo controller, and our test machine controller installed and running on this cluster. So the only thing that we have to do to trigger this test run is we create it with the kubectl command. And as you can see on the right side, now the test run is popped up and the controller automatically creates this workflow in Argo. So let's see what is picked up by the test run. Therefore, I get the integration test. Oops. Get integration test. Let's see. Okay, not there. Because I want to show the status of it, I just get status and then parse it to my editor. So, YAML. So there we can see what the test machinery picked up. And what is interesting here that we have defined that we want to execute our shoot app test once, and then we want to execute all default that can be found in the repository, and therefore we found the seed logging test and the shoot app test, which is executed in parallel, or which is set to be executed in parallel. So then I want to show you the execution in the Argo UI. So you can see that it's really executing there. There we can see our test run that we currently deployed, and we can see that currently the shoot app test is running and yeah, it's doing its job. So until the tests are finished, I want to jump to a real workflow that we are using, or that we're using internally. So there you can see how normally a test look like creating a shoot, then running some tests in parallel. And we also run our conformance test like this, as you can see here. And then the linear shoot again. So this is our basic or normal test run that we use internally to run our integration tests and to test different environments. So let's jump. Right. I think this takes some time, so like 3 to 5 minutes, but I think you get the point that Argo is now executing everything in its workflow, as you can see here. And so now we can see that the seed logging test and the shoot app test is running in parallel, as expected and as defined in the test run. So for now, we store these data in an Elasticsearch database, but to get a better reporting or to get a better benefit of our running tests, we are currently experimenting with some Kibana dashboards. I can show you one thing here, where we want to get a quick overview about the health of our system and about what is going on in our landscapes. Are there any things that we have to cover? Are there any issues with specific cloud providers or with specific versions and stuff like that? But this is currently work in progress. So this is one thing that we are currently working on and want to steadily improve and get the most benefit out of the data that we are collecting with our tests. So let's jump back to my presentation. There. Okay. So I think I can skip these 2 things. And the last point is I want to give a quick outlook about what we're working on next. So one thing is that we want to automatically create the garden deployment. So therefore, we want to use the virtual garden setup, which has Andreas, I think, presented 2 weeks ago. So we want to integrate this into our test machinery so that we have real have real reproducible builds, and that are independent of our landscapes and about any traffic or any workload that is going on our different landscapes or different systems. So this is one thing that we're working on. And we want to have a public test machinery, which means that we want to include external stakeholders to write the tests and to include them into our test machinery, so that you guys or any other stakeholder can have some influence on our release decision or on the stability of Gardener. So everyone can improve this and can be integrated into that. And therefore, the next point is also to have a public reporting. So the dashboard that I showed you before, the Kibana dashboard, really meant to have a public one of that, so that also the outside community or the community itself can see the stability and the quality of the current Gardener and what is going wrong, or what can be improved. And also, of course, we want to write more tests, we want to include more tests to, as I already said, improve the quality. And so therefore, first of all, thanks for your attention. And if you want further information or dig deeper into our test machinery, you can have a look at our GitHub repository, which is in the Gardener org. And if you want to get a more detailed view about our design draft and about our contracts, you can also see it in our documentation on GitHub. So thanks for your attention, and any questions so far?
I've got one question. The test runs explicitly specify a revision for each of the repositories where tests reside in. How do you handle this? I mean, you always have to change this test run definition for each test run?
So exactly. So in our normal, I think I jumped back. So this is a hard-coded CRD, but as you can see here in this picture, we have a test runner. And this test runner automatically reads this component descriptor of our CI system that Christian presented last week. So we automatically parse this and include all repositories and versions into our test run. So this is dynamically templated with Helm and with the test runner.
Okay, so you only check in a template and then the test runs are generated by the CI.
Yeah, exactly.
Okay.
And these test runs are one time. So they're just Helm templates and we deploy them, and then they're one-time runs.
And the template itself is checked in with the source code, or is there a special repository where they reside? Or
the test run there will be one central repository where we handle test runs. So because we want to have specific test runs for, like, for example, for a release decision, we want different test runs, or we want to test different things than, for example, in our 2 hours cron job, or we want specific test runs or specific tests when pull requests come in or stuff like that. Yeah, and there will be one central repository that is managed by us with the test run.
Hi, this is Vasu. I have a question. Kudos, very nicely designed. I want to test the boundaries of where we can, for example, include external, say, sources or code which our open source community may come up with. So because you can fetch from other repositories which are not owned by us, how do we ensure that if we have, for example, some other community member creating a GitHub repo and saying, I have this small item, I would like to include it in the test, but how do we ensure that the security is enforced, that he cannot do something with our credentials? Or
So this is enforced because we own these test runs. So this is because we have the central repository that is owned by us, and where we can decide what we want to include and what not. So what we imagine the process is that someone makes a pull request to this repository, and adds his own repository with the test in it with a specific revision. So then we can review this repo and see, okay, nothing is going on wrong, and then we include it or not.
That's okay, but then in his repo, he's free to add other
It's
labels.
free to add, exactly.
So there is a trust relationship which has to be.
But he specifies a revision, so a comment hash.
Okay.
And as long as he cannot manipulate this comment hash, we are sure that he just that we use the version that he specified in the test run.
Okay, nice.
So even if he add new versions or edit something, he still come back to us and upgrade the version that is specified in the test run to get his new code running. Yeah.
Very nice. Good. Then so we're now open for tests.
Yeah, sure.
Which the community comes up with.
Yeah, this was the intention. Exactly.
Thank you.
Speaking of the tests from community, I was actually hoping to use this for the HCD's performance regression I'm working on. Just wanted to know to test it locally. I would then have to set up the TM controller and Argo in a shoe cluster of my own, right?
So yeah, you can do that. So this is just to install the test machinery. We also have documentation on our GitHub site. So the only thing that you have to do is run 2 make commands, and then the Argo and their repository and their dependencies, as well as the test machinery and the latest test machinery controller is automatically installed. But you can also use Minikube. So we're not bundled to any Gartner-specific cluster, so we run in every Kubernetes cluster.
All right, thanks. I'll try it out.
Yeah, thanks.
And as Tim said, actually for running locally or developing tests, you can as well deploy the stuff with 2 make commands into Minikube, which gives you an additional option to actually mount a local path of your local computer, so that you don't have like a whole roundup cycle where you change a line in your tests and submit it to some GitHub repository so that the test machinery can fetch it from there. But in the local scenario, you can actually map a local path of your computer into Minikube and have the test machinery fetch your test code from there, just to speed up the development cycle.
All right, thanks.
Any other questions? Okay, seems not the case. So really want you to look at our repository, maybe give some feedback. So we are currently work in progress, as already stated at the beginning, and we really like feedback and get you to test it and to have some feedback for us. So
write tests.
And write tests, yeah.
Okay, thank you, Tim. Then the next is Rafael.
Yeah, hello. Do you hear me?
Yes.
Great. Please share. All right, I guess you see my screen.
Yes.
So I'm starting here at this extensibility proposal document just to show what we have done. So here is the section where we have described which CRDs we plan to create that will be used for communication with the extension controllers running in the seeds. And the first one that we have implemented is, which is now not anymore this name, but renamed to operating system config. So we have externalized the knowledge and the information about the CoreOS operating system that we install by default, and should now be up to any other operating system that wants to be used with the shoe clusters. Okay. Then, as already explained in last week, I guess, the week before, we are developing the extension is currently in this repository. And if you want to find the CoreOS extension controller, it's in this location. And yeah, basically we are reusing in this repository common libraries for all the extensions, and do that in order to gain some speed at the beginning, to not so that we don't need to rebase and re-render the same library functions in every controller. But as soon as this is, has stabilized in the next weeks, we are going to move them out into dedicated repositories. Okay, let's go back to the proposal. Because that's now the first extension controller, I quickly wanted to go over the registration contract that we have established. So every extension controller is registered first to Gardener with such a YAML resource. And the interesting part is that somebody has to state which extension resources, so which of the CIDs that I explained previously in the document can be managed by this extension. So in our case, we will have the kind operating system config and type CoreOS. If somebody would implement an, I don't know, Ubuntu controller, then it would be of type Ubuntu. And then there's the question, how does these controllers get into the seed cluster? And so we have decided the general contract is that there is some other controller running in the Garden cluster and observing these resources here. And this has knowledge about how to deploy the controllers into the seeds. In most cases, the deployment is relatively easy. So it's in most cases just a very simple Helm chart with a few resources in it. So we provide in the Gardener itself one type of deployment, which is the Helm deployment type. So in case this here is not uncommented, and some Helm chart is provided with some static values, the Gardener will install it. If this section here is not present, then the responsibility is with some other controller. This is also described here in this section. Okay, so when the Gardener or when the operator, some human has created these resources here, Gardener will, for every seed cluster, create such a controller installation resource, also in the Garden cluster. And this has a reference to the registration and to the seed cluster. So that's basically the order to deploy this extension into the seed cluster. And whoever is responsible, so in case it's the Helm deployment, Gardener will do it itself. In case it's some external controller, then this controller must now start to deploy the extension and report back in the status whether everything works fine. And that's basically the contract, how the controllers get into the seed. We'll now show that in the demo cluster. So we're here in the Garden cluster. And when I list the controller registrations, we find our current 2 extensions. Let's take a look at this one here. As you can see, it is responsible for the operating system configs of type CoreOS. And so this is specified here in the resources list. And we decided that we just provide an easy Helm chart of a specific version. So in the end, Gardener will deploy this controller itself. So now that we have a few seeds, Gardener has created these controller installation orders. So currently we deploy every extension into every seed cluster for the sake of simplicity. In the future, we will make the Gardener more intelligent and only deploy the extensions in those seed clusters where they are really required. But this will be a step in the future. So let's take a look at this one, for example. This is now the order of Gardener to deploy the CoreOS controller into the GCP seed. And yeah, as we saw in the example, it's just a reference to the registration and the seed cluster. And in the status, there are two conditions that more or less report whether the installation has been successful and also whether the registration has been successful. So in the end, this is the contract installed true or false in order for Gardener to know whether the extension was successfully installed or not. Okay, so now in the seed cluster, for every extension, Gardener creates a dedicated namespace. So when we check back the installation resources, we see this namespace here. This installation corresponds to this namespace. And whatever has been part of the Helm chart has been deployed into this namespace. In this case, it's just this deployment, some cluster role, airbag definitions, and that's it. But it could be anything now. All right, and as seen here in the conditions, the status has been reported that the installation was successful. Do we have questions to this part before I continue with the CoreOS controller demo itself? Okay. So then I have prepared a few slides just to show. Oh, let's change. You see the slides, right?
Yes.
Yeah. So now that we have these extension controllers, Gardener must somehow make use of them. So instead of creating the CoreOS config himself, it writes the CRD, and that's visualized now here. So how it worked previously first, that's the Gardener, and everything was in tree. So somebody has created a shoot, and in the spec at some specific place, there was a reference to the machine image that should be used. And Gardener has read this information and understood it and generated then the CoreOS specific configuration in this case, which later was passed to the machine controller manager. And then the machine controller used this configuration in order to create the machine with the provided user data. All right, so how it works today. In the seed cluster, we have, as seen in the namespace, the extension controller running. The registration has been applied to the garden cluster. And now, when somebody creates a shoot with a specific machine image, Gardener does no longer create the config directly, but it writes the CRD into the seed cluster. And this CRD is then observed by this controller. So it watches this. And now it has the logic for doing the generation and reports back the config and the status, or however the contract is. And then Gardener reads that and passes it to further components that need it, so the machine controller, which then again uses it for creating the machines. Questions to this process?
How does the CoreOS extension and the machine controller manager work? At least from the arrow, it is not obvious to me how that works.
How the CoreOS extension controller works? Or
with the machine controller manager, that is not clear to me fully, at least from the picture.
Yeah, so the CoreOS extension controller does not know anything about the machine controller. It just knows about the CRD resource here.
Right.
So
how does the machine controller get the image and other details?
That is provided by the Gardener, as it is today.
Oh.
And so the Gardener has a flow, and yeah, it has an opinion on how the shoot clusters are created. So in this case, it has the opinion that it needs to be done by the machine controller. So it controls how the information flows between the different components.
Mm-hmm.
So it first gets the information from the CoreOS controller, and then at some later point in time when the cluster is ready to now get the machines, it passes this information to the components that need it. So in this case, the machine controller manager. So the extension controller itself is very small and has not much, it doesn't know anything about shoots, right? It only knows about this CRD and the domain-specific knowledge, in this case, the CoreOS, how the CoreOS needs to be scrapped.
Okay. If I understood right, in the future, when
what in the future?
Pool, a controller is introduced, then that might be an intermediary between machine MCM and Gardener. In the future, if a worker pool controller is introduced, then that would be an intermediary between MCM and Gardener. Is that correct understanding?
Yeah. So in the future, the worker pool controller will, so at this point in time, Gardener deploys the machine controller manager, but this will change in the future when we have the next extension controller ready. So the colleagues have prepared the out-of-tree machine controller implementation. That means that Gardener can no longer deploy the machine controller because it doesn't know about the out-of-tree provider image. So that means that the worker pool controller will deploy the machine controller, and Gardener will just pass the operating system information to the worker pool controller, which can then do whatever is necessary in order to create the machine, which is, of course, the same, more or less the same process like today, passing it to MCM.
Okay, understood.
Rafael, may I ask a quick question?
Sure.
Just wondering, is the scope of the whole thing, is it, could this be, is this a general controller registration for controllers that are generally interested into extending somehow the Gardener cluster? Just to give you an example, let's say a controller that's interested in some CRD of its own that it takes care of, and maybe wants to do something in the seed as well. So would that be applicable in this case too, or it's scoped in a little differently?
No, so that's also scoped here. So we only have this one controller registration resource, and we have different kind of resources. So currently Gardener does only support this kind of CRD, right? The others are not yet implemented.
All right.
In the future, there will be others like worker pool, infrastructure, whatever. And we will also have a kind generic, which is anything that is not part directly of the shoot creation or reconciliation flow, but just anything else that might be needed to adjust it by some extension controller. So, and then you would just write kind generic and type whatever. For example, the cert service. So currently we have the cert manager and cert broker support in Gardener. That's one good example for something that is not at all necessary for the shoot creation, right? So the shoot can also live without these two components. And we plan to move that one out into an own extension controller. And if somebody wants to use it in the Gardener system, then just registers this controller, which is of kind generic, and type cert service or whatever will be the name. And then as part of the shoot reconciliation, it is made sure that the necessary components are deployed.
All right.
I think that will be clearer when we have implemented the first example.
I have a question. It's not clear why Gardener needs to be aware of the different kind of controllers are being, or stations that are being deployed. I mean, shouldn't this workflow be the same for all of them? I mean, what makes this operating system config special? At the moment of registering it, I mean, you know the function is why is it special?
Yeah. The reason is because Gardener has an opinion on how the shoot should be created. And right now we have all the clusters independent of the cloud provider in a homogeneous way. And this is a strong feature, or however you want to call it, which we don't want to lose. So we could say we just make the shoot resource publicly available in the C cluster, and then all the necessary controllers can do whatever is needed to create the shoot. But this will lead after some weeks to heterogeneity. So all the clusters will look different, and maybe we will go there in the future, but as the first step, we want to keep the control in the Gardener and keep Gardener's opinion on how the clusters look like.
Okay. The second question I have is like this interaction between this flow that you're showing in this slide, that the Gardener station, my understanding is that the station creates these, basically create the config, the calc init that is needed for initializing the machine. And but the interaction of this with the machine controller is the one I don't understand. Because my understanding of the machine controller only creates the external resource, so to speak. I mean, using the cloud provider, and the machine will pick this cloud init. But how is this happening here?
Okay, so in the specification, Gardener basically writes what it wants the machine to look like, or how it wants to look like. So which files and which systemd units are needed. Then the CoreOS controller computes the configuration and more or less puts the configuration into the status of this resource. So that's the complete rendered configuration. And Gardener reads the status and passes this without understanding what's the content to the machine controller.
Okay.
So for the machine controller, in order to create the machine, the contract is just to pass some user data, right? So the machine controller also does not know anything about the content. And the same is now for Gardener, the situation. It does not know anymore what exactly it is passing, but the extension is responsible for making the configuration correct.
Okay, I see.
We can also see it in the live system. So on the seed, we can check for one shoot namespace now, operating system configs. And you see Gardener creates 2 operating system configs of different purposes. So there's one purpose provision, and this is the configuration that is really passed to the machine controller manager and only executed once during the first machine creation. And the other one, of purpose reconcile, contains the actual systemd units and files that are needed for the machine to join the cluster. So for example, the kubelet service, the kubelets, whatever configuration and so on. And the difference here is that this configuration might be updated by Gardener in the future. So maybe in the future it wants some other systemd service on every machine. Maybe it wants some other file. And then the cloud config downloader script that we run on every worker machine is fetching that again and applying this. And that's the difference here. So the provision purpose is just executed once during the machine creation, and the reconcile purpose might be executed multiple times in the lifetime of the machine.
The provision is the one that which is passed to the machine controller, right?
Yes, exactly.
And the second one is picked directly by the worker machine.
The second one is downloaded, exactly. Yeah.
Okay, I got it. Thank you.
So here, for example, Gardener wants or passes the kube config for the cloud config downloader and its credentials, more or less. And then it passes the script. So this script is then executed on the machine and downloading the real configuration that contains then the kubelet service and so on. So that's the specification written by Gardener. You see it's only one systemd unit service, the cloud config downloader that is here, executed every 30 seconds in order to check whether there's a new version of the actual cloud config. And the operating system config controller, so the extension has seen this and has put in the status the information that it has basically reconciled this resource. and the generated user data can be found in this secret here in this namespace. So Gardener sees, okay, reconciliation has been successful, and then it goes ahead and reads the secret, which contains the operating system config, and yeah, later passes it to MCM. So that's the flow more or less now. And previously it was just directly computing the content of the secret and passing it to MCM. And now we have this indirection. Okay, so what I also wanted to show is here, Gardener docs directory. We have written some hopefully detailed documentation about the contract, the registration process, and some general overview. So in addition to the proposal document, you can check it out, and yeah, it would be good if you could provide some feedback whether you think somebody that wants to write another extension could understand what needs to be done out of this document. And if not, file some PRs, that would be cool. Good. So then maybe interesting, this one is merged already to the master branch. We are currently cleaning up some things, and hopefully in the next days create a new release that really then contains this change. So check out the release notes of this pull request, which are not yet visible, of course, because there is no release yet. But in case you have pulled the latest master branch, then you need to do some changes in order to make your local development setup work again. So for example, you now need to register these extension controllers in your local garden cluster and so on. So that's the pull request 7.13. Okay, so then just quick overview, what we are currently now, or what's the next step more or less. So here in the overview document of the extensions folder, we have a small status report, what needs to be done. So the operating system config, it's called in as it should be CoreOS, of course, that's completed. Some colleagues are working on the DNS extension and are finalizing that. So we have a DNS controller in the Gardener organization that supports all these providers. Then we are and have started the work on the infrastructure resource. So this one, that will be the next, probably, maybe DNS also. And then we will get to the worker pool config. Okay, I guess I have used too much time. Sorry for that.
Thank you, Rafael. I think it's an important topic, so it's okay if you took a bit longer. We have one more. We have one more topic by Peter. So please go ahead.
Okay. So let me share my screen. This one, I guess. Okay, so I want to talk about release notes, and not about Gardener release notes, but release notes in general. So I will talk about the syntax for flagging release notes, where to put the release notes, and about some features like draft releases and release note transport. So release notes has to be flagged as such, and that's why, based on the syntax that also Kubernetes uses for building release notes, we have our own syntax. You have a, let's go into presentation mode to make it a bit larger. So we have a code block, and in the header of the code block, we have you can specify a category and a target group. And the categories, for example, if you have an improvement, if you made an improvement like a fix or something like that, or if the release note is noteworthy or contains most notable changes, or if you have some, or if an action is required by a user or an operator which is under the target group. And at the bottom here, you can see also an example for a release note. Okay, so now that we know how the syntax looks like, where do I put the release notes? And there you have two options, either as just Rafael showed it in a pull request, which is the preferred option, or you can also put your release notes as commit message. And here, for example, is an example or a snippet of a release note of the Gardener component. And here is the target group, which is user, and I didn't have the category on this snippet. But anyhow, when I click on this link here, which is the commit, you can also see how the release note looked like. So here's the code block, the category, and the target group, and of course the release note itself. And okay, coming back here. So why is the pull request the preferred option to put your release notes? It's simple because you can change your release notes even if the pull request is merged. But when you put it in a commit message, your release note, and you push it to master, then later on you see that you have a typo or you want to change it, then this is not possible anymore. So that's why I would suggest you put your release notes in a pull request. Then we also have support for draft releases, and draft releases contain release notes of merge pull requests and commits, and which gives the benefits that you see how the release notes would look like. But there is a drawback. You need to have write access to the repository to view drafts of releases. Yeah. And usually, but this is configuration, they are updated or created on every head update. And please also do not edit the draft releases, or if you do, the changes will be reverted on the next head update or on release. The release notes are fetched from the pull request directly in the commits. So if you want to change your release note, go to your pull request, change the description, even if it's merged, and before the release, you can still change it. Okay, and we also have built something to transport release notes. And why do we want to do that? We want to include release notes of dependent components in the target component. For example, the Gardener has a dependency to VPN or Machine Controller Manager and so on. And when those components do a release, their release notes are included also in the Gardener release. So we can see here, for example, Gardener release 016, we have several dependent components, and also, of course, the Gardener component and the release notes. And also for each landscape, we have like dev landscape or canary or live landscape. Each landscape is also a Gardener component, which means we also have release notes for each landscape, and without any special coding, we have the benefit that we also can include the release notes of the dependent components of this landscape. For example, canary landscape, or every landscape has a dependency to Gardener, to the Gardener dashboard, and so on. And because of the release note transport, we can transport the releases inside each component, and from when we transport it to dev, and from dev to canary and so on. So you can see when you look at the landscape repository, you can see which feature is in which release of the landscape component. And how do we do it? On each release of a dependent component, an upgrade pull request is created, and I guess Christian also mentioned it last week, the upgrade pull request. And here's an example of how this looks like. So this is an example of the Ghana component. A machine controller manager did a release from 0.11 to 0.12. And part of this pull request are also the release notes. And as you can see here, there are multiple code blocks, and the header contains the category and the target group, but it also contains, which I didn't mention before, because it doesn't matter if you create release notes on your own, is where the release note comes from. So you do not have to specify that. It's just for the transport relevant, and the pull request or the commit ID, and also the user. So going back, and yeah, all release notes since the previous release are included in the upgrade pull request. And yeah, that's already it, what I wanted to say about the release notes. If there are any questions, feel free.
Thank you, Peter.
Okay.
So this concludes our today's community meeting. See you next time, next week on Thursday afternoon. Bye-bye.
Bye.
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 Bye-bye.
So, dann der Meeting.